welcome to yet another episode where we shall be looking at the mathematics paper 1 for grade 10 June examination prediction. Okay, now I'll be using this question paper and go through with you guys the few questions that we've set up just to help you prepare for your June exams. Okay, now the June paper, especially the maths paper 1, minimum marks is usually 50, but it can be 75, or we can even have it as 100. Okay, so this should be the range between 50 to 75, or between 75 to 100. Anyway, okay, depending on what the examiners really are interested in. Okay, so now I'll not dictate to say no, your paper is going to be having 75, your paper is going to have just 50, your paper is going to have 100. No, it will depend. Okay, so some people would prefer to test almost everything, which would take the mark to be maybe to 100 or even 75. But if it's just testing just small bits, then we could have just a 50 mark paper. Okay, so with this one, it's a 50 mark paper with a duration of 1 hour. Please, if it's 50 marks, the duration must be 1 hour. If it's 75, it's 1.5. And then if it's 100, that's going to be just 2 hours. That is how it is. There's nothing like extra time or more time for people to write exams. Okay, so the topics that we can anticipate for the paper 1 in mathematics. Okay, remember this exam must be a combination of term 1 and term 2's work. Okay, but of which we know that in term 2, whatever work is done is mainly for paper 2 and not necessarily paper 1. So the work that was covered in term 1 should be the work to be discussed mainly in paper 1, except for trigonometry. Okay, so number 1, we must expect something like types of numbers. Okay, that's sometimes we call it the number system. Okay, the number system. Then 2, we know that there is algebra, but this algebra is broken down into, we can have products. Okay, products, we can have factorization. Okay, we can have fractions that involve factorization. We can have equations, different types of equations, from linear, simultaneous, exponential, all those things. And then we also looked at what else? I think basically that's what was covered in term 1. In term 2, what should be covered should be what we call the functions. These functions are also known as what? Graphs, specific graphs that we look at. So I'll just use the questions that we come across just to throw more light onto the different aspects. So in this case, we had 5 questions that need to be answered only. And then they tell us that the answers must be rounded off to 2 decimal places unless they tell you otherwise. So sometimes they can tell you round off the nearest 10, nearest whole number, or even leave the answer as a salad. Okay, so we just need to pay attention to that. Okay, so question number 1, which is the number types or the number system. This is accounting for just 3 marks in this paper. Now they are telling us that if X is an element, that E means an element or is a set. Okay, X is a set of 0, 1, 2, 3, and 4. Write down a value of X such that K, remember that all of this is K, is undefined, rational, irrational. So in other words, we must choose the answers from this set. So when something is undefined, one thing we need to know is that the denominator must be a 0. So if you have, let's say, a over 0, then it's undefined. We don't care whether it's under square root or a cube root or what, but for as long as the denominator is a 0. So which number can I replace with X here to make this denominator 0? So meaning that X has to be a 4. So if X is a 4, then I'll have the undefined. We're done with that. Then for rational, We know that something can be rational, a number is rational if it can be expressed as a fraction. So in this case, since we have a square root sign, we need to look for a number that is gonna give us a perfect square inside here, so that whatever is left in the square root, we can find its square root. So chances are high we have more than one number here. No? We have more than one number. That's what I'm thinking. So 1, if x is a 0, we're going to have 9/4. We can find the square root of 9/4, which is a 3/2. That is rational. Okay. And then if x is a 3, if x is a 3, because it will be 4 minus 3, which is a 1, so it's just a 9, which is a 3. So I think one of the two, because they said write down a value. Okay. And then if it's irrational, meaning that we must get anything else other than a negative. Okay. So if we replace x with a 1, we're going to have a 9/3, which must give us square root of 3. That's irrational. Perfect. If you replace x with a 2, that is also giving us irrational. Yeah, I think just this way. Any. Remember, we need just one. Then under this question, sometimes they can ask you to write numbers as rational. An example, they can give you 0.23, and they put those dots, and then they can tell you write it as a rational number. Can you show, can you prove that this number is indeed rational? So we need to know those steps of how to go about that. Okay. So I just wanted to put that out. Sometimes they can also ask you between which two integers do we find, let's say, an irrational number, let's say √5, between which two numbers. So that we need to also remember. Then 2.1, simplify the following. The word simplify means break it down. If we have brackets, you need to open up those brackets. If we have fractions, we need to use the knowledge of fractions to break it down. Okay. So we have 2b into b minus 5c, but everything is square. So I'll say it's a 2b into a b minus 5c into a b minus 5c. Let me open it bit by bit. So 2b, I know that this and that's going to be a b squared minus b, and the 5 is going to be minus 5bc. And then this and that minus 5bc, that and that's going to be a 25, but c squared. Then I'll open it up using the 2b again, and then I'll later simplify. So that's going to be 2b cubed. This is 5, this is 5, it's going to give me a negative 10. That's going to give me negative 20 b squared c. And then I have a 50 bc squared. This becomes my final answer for 2.1.1. So remember, with opening brackets, we can have a monomial with a binomial, a monomial by a trinomial, a binomial and a binomial. We use the FOIL, okay? And so on and so forth. Then we have this question. 3x minus 2 times 3 to the x minus 1. And let me just put that question on a blank page and see. Okay, so we have 3x minus, we have 2 times 3 to the x minus 1 over, we have 3 to the x plus 2, then plus 2, 3 to the x plus 1. Okay. So what we normally do with this is that whenever we have fractions that have exponents, okay, and even if it's not necessarily fractions, but for as long as we have exponents that have a negative sign in between the terms, okay, we have a negative, we have a plus, we need to do what we call factorization. But Looking at this question, I can sense that there could be something wrong with this x here. Chances are high it was supposed to be 3 to the x. There's no way you can put this x as a multiplication. So what I'm going to do, I'm going to change that into a 3 to the x to make life easy for everyone. Okay, so that's going to be a 3x. When I simplify that, that's going to be a 2, 3x, 3 to the negative 1 over 3x, 3 to the 2 plus 2 times 3x, and then 3 to the 1. Remember, I'm using the first law of multiplication to do this, the breakdown. So what is common is 3 to the x. When this goes, I have a 1 minus. I've taken out this, meaning that I'm going to be left with 2 over 3. Over, we take out the 3 to the x. I'll be left with 3 squared, which is a 9, plus, that's going to be 6. So this cancels that. And then I'm left with this fraction, 1 minus 2/3. I'm going to be left with just 1/3. And then I'm dividing it by 9 plus 6 is 15. So it's 1 over 3 times 1 over 15, meaning that our answer becomes 1 over 45. Okay, so that's how that question would have been worked out for 3 marks. Then factorize completely. So when they ask you to factorize completely, it's like you can use more than one method to do the factorization. Break down that expression to a point that you can factorize it further. Now the question is, how many terms do we have here? We're seeing 4 terms. Now, if ever we have 4 terms, grouping is the way to go. Okay? So I'll group this, and then I'll group this with a plus sign in between. So what's common at the front? Is that going to make sense for me? Doesn't feel like it's going to make sense. Let me rearrange this first, because if I group it directly, then it's going to cause issues. Let me take this one there so that I have a squared minus 1 minus ax plus x. And then I'll do the grouping at this level. Now that this is a minus 1, a plus 1. Okay, plus what's common here is the x, but I'm going to take out a negative x so that I can have a positive a. So negative x comes out, I have a minus 1. So if a minus 1 is common, okay, then I'm going to have a plus 1 minus x. And then this becomes our final answer. Then 3.1, they want us to solve. So these are equations. Solve for x. Remember what we said, that you cannot cross x's out. Otherwise, you'll be killing solutions. So since the 3x squared is equal to x, let's move this 2x to that side, because this degrees 2, which is a quadratic equation. Okay, so we have 3x squared is equal to x. Remember we said move this that side, so 3x squared minus 2x is equal to 0. What's common? X is common. We take it out. We shall have 3x minus 2 is equal to 0. Now we know that from our dot product, if we have a times c is equal to 0, one of these must be a 0. So either x is a 0 or 3x minus 2 is a 0. When we solve this, move the 2. 3x is a 2. Divide both sides by 3. Okay, and then there we go. Then 3.1.2. Equations with fractions. Okay, so we have 7 over 3 minus x, okay, is equal to 5 over 3 plus x plus 4 over x squared minus 9. Okay, question is, what do you see? We're seeing a 3 minus x, we're seeing 3 plus x. We know that these are usual factors of a number that is 9 minus x squared, something like that, okay? So what I'm going to do, first of all, I can introduce a negative sign here and then change this so that I have negative 7 over, this is going to be x minus 3, is equal to 5 over, I will change that, x plus 3, and then 4 over, let me factorize this, x minus 3, and then x plus 3. Then whenever I have fractions, aim at eliminating the denominators. Okay, so I'm going to multiply by the biggest, which is x minus 3, x plus 3. Same thing here, x minus 3, x plus 3. And then the same story here, x minus 3, x plus 3. So this cancels that. I'll be left with a negative 7 multiplied by the x plus 3, which is going to be negative 7x minus 21. This cancels that. I'll be left with 5x minus 15. These two will cancel. Then I'll have something like that. Now, denominators are gone. For as long as denominators are out of the way, then life is easier for me. I'll move the 5x to that side. So negative 7x minus 5x. Then I'll have negative 15 plus 4 plus a 21 when I move it aside. So this is going to give me negative 12x is equal to, that's going to be a 25 and a 15, which is like a 10. Then I'll divide both sides by negative 12, meaning that our x is going to be 5 over 6. Should be 4 marks. Yeah, perfect. Then 3.1.3, we have the exponential equations. Oh Lord. We have 16,2 to the exponent of x minus 1. Okay. 16,2 to the exponent of x minus 1 is equal to 0,5 to the exponent of x minus 4. 4 marks also. Okay, so let's see. What do we need to do? Wait a minute. When you say 16,2, is it like a 16 and then 2 to the... Wait a minute. Because it's possible that it's a 16 times 2 to the x minus 1, and then this I have to the exponent of x minus 4. Something like this. But it's okay. It's okay. I'm not going to dispute anything. I'll just work it out the way it is, and we see. If it doesn't give us what we need, then we might have to change it for convenience, okay? So if I have, let's say, 16,2, is it possible for me to write that 16,2 as a fraction? It's going to be 81 over 5, which doesn't make sense now, because I know that 0,5 is going to be a half. So in other words, there has to be synergy between the bases. So since there are no brackets, this is supposed to be a times. Okay. Okay, so I feel that's the only logical explanation that can be made. We cannot have a 16 comma something. So this should be 2 to the exponent of 4. This is 2 to the exponent of that, okay? Then this side, we know that a half is the same as 2 to the negative 1. But now we're multiplying it by something like that. Let's simplify this. Bases are the same. We must add up the exponents. 2. That's x minus 1 plus 4 is 2 negative x plus 4. simplifying this, okay, let's drop the bases, no problem. That's going to be x plus 3 is equal to negative x plus 4. Let's move this on that side. We're going to have a 2x is equal to 4 minus 3, which is a 1, meaning that our x is a half. So this is the answer to that question. Okay. Then 3.2, if you're given this inequality, they want us to solve it. So whenever we're solving inequalities, just treat them like normal equations, okay? So the first thing I'm going to do, let me move this 2 to that side. I'll have negative 3x over 4 is less than 12. Then I'll multiply both sides by 4. So negative 3x is less than 48. Then I'll divide both sides by negative 3. Now remember, whenever we divide by negative with inequalities, the symbol must change. Okay, so that's negative 16. Please just confirm with me what is 48 divided by 3. Okay, 48 divided by 3. Said 48, not 45. Okay, yeah, it's a 16. So if it's a 16, then simply means that this is the solution, okay, that the question wants. Then, if that is our solution, the question is, what is the first natural number that will satisfy the inequality? Remember, natural numbers are basically counting numbers from 1. So the first natural number that will satisfy, remember, x must be greater than negative. This meaning that the first natural number has to be just a 1. Okay, so you can say x is 1 or just 1. Okay. Then 3.3, they want us to solve this simultaneously. So 2x plus y. Okay. 2x plus y is equivalent to 8. And then the other equation is 2y plus 3x. 2y plus 3x is negative 2. This is 3.3. Okay. So remember, we have 2 methods of solving this. We have the substitution, and then we also have the elimination. So if by any chance I call that 1, I call that 2, I would say from equation 1, let me make y the subject. It's going to be 8 minus 2x. Call that equations 3. And then I'll substitute 3 into equations 2. Okay. Then if I do that, where there is y, I replace it with that. So it's going to be 2 into 8 minus 2x plus a 3x is negative 2. We open up. So 2 times 8, that's a 16. 2 by 2, that's going to be 4x. Plus a 3x is a negative 2. Simplifying this, I'll have negative x. When I move the 16 to that side, it's going to be a negative 2 minus 16. So negative x is equal to negative 18. Then divide through by negative 1, meaning that x is going to be 18. So if x is 18, then I need to get this answer and then replace it into equation number 3. So substitute x into equation 3, meaning that's going to be y is equal to 8 minus 2 times 18. So 8 minus 36. Does it give us a 24? Nope, people are refusing. It should be something like 18. It has something with 8 at the end. Guys, let me just use my calculator so that we don't get to answer. So y is negative 28. Okay, so that is how we go about with solving simultaneous equations. So looking at question 1 to 3, that's basically typically term 1 work. Okay. Then question number 4, which is the functions. Consider the functions below, consider the graphs below. Fx is x squared plus c. So we know that this is a parabola. Okay, if that's a parabola, g of x is a bx plus q. This is a straight line. They're telling us that both graphs intersect at -1 and -3, and then at b, which is 2 and 0. They want us to calculate the values of a and c. How many marks? 4 marks. So what we're going to do, we're going to use the 2 points, this point and that point. We are back to simultaneous. So we have ax squared plus c. Okay, remember this is our f of x. But which equations are we using? -1. Now which points? -3. And then we also have 2 and 0. That's a, that's, so let's substitute. We know that this f of x is the same as y, ax squared plus c. So if I use point A, I'll have -3 is equivalent to a into -1 squared plus c. Okay. Simplifying this, I'll have -3 is equal to a plus c. Call that equation 1. Then I can also use that. Substitute, we have 0 is equal to a into 2 squared plus c. Simplify, we have 4a plus c. This is equation. Okay, so we said that when you subtract the 2 equations, this is what we end up with. So our a is a 1. Then we need to substitute this one either into equation 2 or the first equation for us to determine the value of c. So I'm going to use the second equation because it looks a bit simple. So that's going to be 4 into 1 plus c is a 0, meaning that our c is a -4. Okay, so we've answered just the first part of the question. Then 4.2, they want us to get the values of p and q. So remember, both graphs are meeting at these points. So for us to get the equation of a straight line, we know that this b represents the m, the q represents the c. M is for the gradient, and then this is the y-intercept. Okay. So with the gradient, let's see. So this is 4.2. A is -1, -3. We say B is 2 and 0. So gradient is changing y over changing x, meaning that it's a y2 minus y1 over x2 minus x1. So if this is my x1, y1, this is my x2, y2. So I'll have something like 0 minus -3 over 2 minus -1. This is 3 over 3, which is a 1. Okay. Then I can use my point B and using this equation for me to get the value of c straight away. Meaning that our y minus 0 is equal to 1 into x minus 2. Meaning that the equation is this, so c is going to be -2. So they wanted the values of b and q. Therefore, b is a 1, q is -2. Okay, so that is that. Then 4.3. 4.3, they're asking us to use the annexure to draw f and g. All right. So let's look at the annexures. Is 4.3. So the first equation, remember, we said it was, what was our a? Our a was 1. And then our c is -4. So it is x squared, just x squared minus 4. This is f. And then the g, remember we got x minus 2. One is -4, this one is -2. Okay. So let me start with the G. They told us the points are meeting at -1 and -3, this point, and then also at 2 and 0. Okay, so that's not a big deal for me. No? My point is that I need to draw the line. With this line, the y-intercept is -2, which is this. Okay, and let's say I have any other point. If x is a 1, let's say x is a 2, y is going to be a 0. So 2 and a 0, meaning that my line is going to be, let me just try to create a straight line. It's a 3, that's a 1, it's a 4, that's a 2. Okay, so I have something like this. Feel free to extend it if you want, but I'll just give it, remember it's a sketch now. So I'll say this is my g of x. Then our parabola, the a is positive, which means it's supposed to be a smiling parabola. So it's passing through negative 4 at the bottom here, meaning that it must go here and must also go through that point. Let me use green. So if x is 0, y is -4. If x is 1, it's going to be -3 for each. No, yeah. And then if x is a -2, then that's a 0. Okay. So we're going to have something like that. Remember, that's our sketch. So this is F, and then that is G. Okay, so it may not be that open, but rather to be in this sort of format. And then that sort of format. Forgive my sketch, guys. What did I do? What did I just do? Okay. Let's drop it. Okay, something like that. So a parabola as well as a straight line. Then the next question is now asking us that determine the value of g of x minus f of x. G of x minus f of x. What this means that if we get the value when g is above, remember g is the straight line, and then f of x. Where do we find g, the straight line, to be above the parabola? When do we find g to be above the parabola? So we can see that from this point 2, yeah? Remember, focus is g, okay? And then this point -2, that's where g is above this area. G is on top, the f is at the bottom. So we're going to say -2 up to +2. Okay, -2 up to +2. So we're gonna say -2 less x less a +2. That's why it's less. Then where do we find g to be greater or equal to f? Where do we find g to be greater? Okay, where is g greater? I think that's the region where g is greater. But now if, Okay, so let me just answer the second question first before I answer the first one. So this is going to be -2 less or equal to x less or equal to 2. Now, g of x minus f of x, you can't say determine the value. Unless if I'm going to give it in terms of the inequality, but this is going to be in the y format, okay? Meaning that it's between y0 and y -4. So -4 and 0, that's the only region that we can really focus on. Okay, so we're going to say that -4 is less y is less 0. This is the only region that we have for this. Alternative, if they ask us maybe g of x minus f of x is equal to a particular number, maybe 3 or 2, then we're going to be in position to determine the value of x. Here, they're not specific. They find the value of x or find, so it's basically the value of y that they need. And then for question 5, which is the exponential, if f of x is 2 to the x plus 2 plus k is drawn below. All right. Use laws of indices to show that this is also the same as that. So we split this up now. 2 to the 2x multiplied by 2 squared plus k. We know that 2 squared is the same as 4. Now multiplied by 2 to the x plus k. That's all we have to show. Then determine the value of k. So value of k, we know that k is the asymptote now, which is a 1. So we don't even need to work it out. If you feel you're indebted to do that, go ahead and use this point of 0 and 5. Okay, where there is x, put a 0. Where there is y, we put a 5. So that's going to be like 4 multiplied by 2 times, so 2 to the exponent of 0 plus k must give us a 5. 2 to the 0 is a 1, so that's like 4 plus k is a 5. Move the 4 that side, so that k is what? A 1. But from the drawing itself, I don't know why they gave people 2 marks for that. It should be something like 1. Then I write down the equation of the asymptote. The asymptote is the same value of k, so y is equal to 1. So that is how we write that out. So guys, I'll stop that. And then I'll wish you guys all the best. If there are any errors, any mistakes that you found within this paper, please feel free to slot that under the comment section so that we can improve and do better next time, okay? For those that have not yet subscribed, please go ahead and subscribe so that you don't miss out on the interesting content that will be coming your way. All right. Thank you very much. Bye-bye.